Hello everyone. Welcome to our presentation, Eyes on the Drive, examining car-free urbanism on Memorial Drive in Boston, Massachusetts. This presentation and the accompanying research was prepared by Johanna Riddle, Jenna Van Holten, Ellie Tavares, and Jenna Whitney, with contributions from Hong Kong Huang and Yosheng Yu. Research was made possible by Tufts University and the Human Architecture and Planning Institute, who share a mutual mission to advance planners' understanding of the human experience in the built environment, while improving its design through education and research. Our mission is to promote evidence-based design using biometrics and other tools to reveal hidden aspects of the human experience that influence human behavior in the built environment. To start us off, I will provide a brief history and background of Memorial Drive, the test site for our research. We will then guide you through our literature review and data collection, what the data told us, and how we can use what we found to guide future research and inform current policy. Located in Boston, Massachusetts, Memorial Drive lies 1.5 miles, or 2.4 kilometers, from Mount Auburn Street to Western Avenue. We chose this site to compare the impact of vehicles in an urban environment and how the same space is reclaimed and perceived by people without vehicular traffic. Our timeline starts in 1964 with a local proposal to remove trees and widen Memorial Drive to ease traffic flow. This movement was catalyzed by citizen activist groups. Vehicular traffic and accompanying pollution presented risk and potential degradation to the soil of the sycamore trees that lined Memorial Drive. In the 1970s, Isabella Halstead founded the Friends of Riverbend Park, a group that sought to make the closing Memorial Drive a weekly event which was run entirely by volunteers. In 2002, the Charles River Basin Master Plan was created as a guide for the management and maintenance of the parklands, parkways, and water basin. This momentum culminated into regular Memorial Drive closures on both Saturday and Sunday in 2020. As of 2023, Memorial Drive is only closed on Sundays from April to November, 11 a.m. to 7 p.m. Our literature review focused on the visual and audiovisual hardwiring humans possess. We discovered that evidence of site reliance dates back to the Pleistocene period. In our research, we found parallels of how Neanderthals interpreted environmental stimuli and how modern-day Homo sapiens interpret visual stimuli. Most notably of these, humans experience soothing in green, nature-designed areas, like trees and rivers, and stress at large, fast-moving, loud elements, like a feline predator. The neurological basis of this innate reaction begins with the fusiform face area, which shape human perception and how we interpret our environment. Your autonomic nervous system is a network of nerves throughout your body that control unconscious processes. Unveiling this internal process helped us understand unconscious preferences and dislikes to natural stimuli. To relate our findings back to vehicles and Memorial Drive, we sought to understand how exposure to vehicular traffic has evolved in tandem with population growth and urban development. We found that in the United States, over 97% of people are routinely exposed to traffic-generated noise above 50 decibels, where long-term exposure to noise levels at or above 50 decibels increases health risk. With this information, we sought to answer two questions. What can the Memorial Drive closure reveal about our perceptions of car-centered urban experiences? How can biometrics advance our understanding of how people unconsciously interact with the built environment? We used a combination of qualitative and quantitative data collection methods to inform our research questions. Members of our team had two conversations, one with Cambridge City Councilor Quinton Zondervan and the head of the Riverbend Park Trust, Pat Seckler, for a high-level bureaucratic perspective. We completed 30 in-person pedestrian interviews along Memorial Drive for an on-the-ground user perspective. In addition, we used two kinds of biometric software, 3M Visual Attention Software, more commonly known as 3M VOS, and iMotions Online. From a photograph, 3M VOS emulates the location and duration of where a person will most likely look at a scene. This software allowed us to flexibly experiment with various visual stimuli and gave us an understanding of what we should anticipate from the iMotions Online study. iMotions Online, unlike 3M VOS, gave us real-time data on real-life subjects. iMotions Online not only collects where a person will most likely look at a scene, but gives a facial analysis as well. The ability to gauge what emotion was elicited from our subjects based on what videos and photos they were shown alludes to the applicability of a Pleistocene era brain in today's urban world.
So to kick off our results, we want to go over our 3M VOS outputs because this acted as a jumping off point for our eye motion study. We wanted to use the software as a validation for our eye motions results, which will come after this. And so one of the outputs was a gaze path, so it showed the top 4 most attention grabbing points in each image according to the software. And starting with that image on the top left, you can see that the 3 vehicles that are present in that vehicle attract a lot of attention to the software. And you can see similarly in that image on the bottom left that contains a vehicle, that vehicle claims that number 2 spot, the number 2 most attention grabbing spot in that image. And in the same image with the same composition on the bottom left and bottom right, without a vehicle, that second spot is not taken by that same area because the vehicle is not present. That area is not even part of the gaze path, meaning that vehicle is having a significant impact on the perceived perception from the 3M VOS software. And when taken in aggregate, we found that 50% of our images that had vehicles, those vehicles ended up in the gaze path. And when the results are overlaid with a heat map, you can see a similar trend. And the heat map, essentially, if it's red, it's a high attention grabbing point. If it's blue, it's relatively high. And if there's no coloring, it means it's just not an attention grabbing point. And in the image on the left, the only difference being there's a vehicle present. That area is not only the number 2 point on the gaze path, but it also has a dark red attention point, and the entire vehicle is paid attention to according to the software. But if you look at that same image on the right without the vehicle, that area almost has no attention whatsoever. So it is having an impact on the perception of space. And now going into our eye motions results, we saw very similar findings. And in this image that we showed to our participants, this image on the left has no vehicle. So you have that road, it's completely empty. And where do people's attention go? They'd go to the middle, that tree, and to the person on the right, which is the same type of findings that we had in our 3M VOS study. The attention just goes to the surrounding environment, any kind of people, if vehicles aren't present. But as soon as you put a vehicle present in that image on the right, that you can see that heat almost grows towards the left. So it's like more attention is being paid towards that road where it wouldn't have been if that vehicle was not there. And so our behavioral study with real participants supported that 3M VOS finding. And the benefit of that eye emotions study is that we could also look at emotional response. So it's not just perception or visual attention, it is also emotions. And as you can see, the vast majority of our participants showed neutral emotions. And although those positive and negative emotions are a relatively small percentage, there is still a difference between the percentages when there are vehicles present versus not. And also, we found there was a big difference if there are people present or not, because that is a very big attention grabbing point. It can impact people's emotions. So we decided to isolate that variable as well so that we could really see what impact vehicles could have on the perception of a space. And as you can see, in most cases where an image it does contain a vehicle, those positive responses end up reducing by just a few percentage points or a few fractions of percentage points, and that negative response similarly increases by a few fractions of a percentage point. And although that difference is small, it was still a significant enough difference for us to dig deeper. So here's an example of just one image and the result that we got. You see this image on the left has no vehicle present, so we found a 9.4% positive response and a 5.7% negative response. And that same image, just with a vehicle in the foreground, you have a reduction of 0.4 in positive response and an increase in 0.4 of negative response, which means that that vehicle alone is having an impact on emotional responses. Although it's slight, it's still worth investigating. When taken in aggregate, you see similar findings. Whenever we had a vehicle present in the image, we detected much lower responses that were positive, 0.9, almost 1 full percent, and the negative responses were also almost 1% higher than the images that had no vehicles
We
present.
detected a
And
shift
we also
in the
decided
amount
to
of time that
detect if
our
there
study
was any difference between
participants spent
vehicles that were
displaying
distant or in
positive
the
and
foreground.
negative emotions
And
based
although there
on
was a
whether or
difference
not there
between the
was a
two, you
vehicle
could still
present
see
in the
consistent
image.
increases in
In
negative
the
responses
chart
and
on the
decreases in
left,
positive
if
responses
you look at the
by
first
varying
bar all the
degrees.
way on the left, you'll see that when our participants were viewing images that did not contain vehicles or people, they spent an average of 9.9% of the time expressing positive emotions and 5.9% of the time displaying negative emotions. When we added vehicles into the image, which is the next bar over to the right, you'll see that the amount of time our participants spent displaying positive emotions dropped slightly to 9.5% of the time, and the amount of time they spent displaying negative emotions rose slightly to 6.3% of the time. You can see in the chart on the right that when our study participants first viewed an image with a vehicle and then another image without a vehicle, the change in their emotional share, which is to say they expressed more positive emotions, was found to be statistically significant. We also took a look at the time to first fixation. So the time to first fixation indicates the amount of time that it takes a respondent or all respondents on average to look at a specific area of interest from the time that they are shown the stimulus, which in this case is an image. Perhaps unsurprisingly, you'll see that in the image on the right inside that red box, we had more participants fixate on that area of the image when there was a vehicle present, so 13 out of 50, and the mean time to first fixation was 955 milliseconds. When we removed that vehicle, which you can see in the image on the left, we had about half as many participants fixate on that area in the image, so 7 out of 50, and the mean time to first fixation about doubled to 1,951 milliseconds. We were also curious how the presence or absence of a vehicle would impact the time to first fixation on the sort of more natural elements that are contained in our images. So we looked at the time to first fixation for the right half of the image and then the left half of the image. In both these cases, you'll see that the only really prominent difference is the presence or absence of the vehicle. So the mean time to first fixation on the right half of that image was 526 milliseconds when the vehicle is not present in the left half of the image. And when the vehicle is present in the left half of the image, the mean time to first fixation is 1,094 milliseconds. So it seems as though cars may be acting as a sort of a sensory barrier, sort of blocking engagement with nature, even though the vehicle itself may not be physically blocking an aspect of an image. So our key takeaways from this research, the first was that statistically significant increase in positive motions when cars are removed from an image. The second is that we feel that we should be building cities for people rather than cars, and that urban planners are really well positioned to prioritize people and planning through nature-based design. And then finally, as I mentioned a moment ago, it seems that vehicles may serve as a sensory barrier to engagement with natural settings. Thank you so much.